Okay, so I'm Alberto Sposito. I'm an associate researcher, project manager at CMI, it's the Cyprus Marine and Maritime Institute. So this evening, I'm going to talk about the need for maritime digitalization, and in particular on the MDGI project, which is about the marine digitalization research infrastructure. And I'll try to minimize this. Okay. So there is a need in maritime industry for increased safety, security, efficiency, and support for environmental sustainability, as the previous speakers also highlighted. And quoting the Blue Economic Report from 2022, maritime transport is an important pillar of the blue economy. However, it also exerts pressure on the environment. And of course, we need to take into account that the port sector is crucial to the European economy. We need a closer cooperation between ports, shipping lines, and other actors in the logistics, and particularly to ensure efficient and smooth flows of the cargo. And we need to take into account that maritime situational awareness, impact on safety, security of and the environment of the EU and its member states. So in this project, we are addressing four so-called pillars, so safety and security, efficiency, and environmental sustainability. And the way to address these challenges is to use new enabling technologies, such as Internet of Things and digital tools, which can provide information and decision support. However, as previous speakers also highlighted, this comes with other challenges, such as shortage of personnel with the necessary skills for both software and hardware development. Also, a lack of data, which the digitalization tries to address. However, once we start collecting data, we have the opposite problem. So how to handle such massive amounts of data, and also how to test and validate our methods, and also how to accelerate the digital transformation, lowering barrier to adoptions. For instance, we know that some, especially big port operators, maritime operators in general, can be reluctant to change. And other challenges are obstacles to information sharing and collaboration, lack of trust between different operators, and competition. So in the MDGI project, we are trying to bring together the so-called quadruple helix actors, so from government, civil society, industry, and academic research. We address both physical spaces we identified for testbed and equipment in terms of Internet of Things and lab facilities. We're trying to address human resources, so know-how and talent, and also bring a new suite of software, like software as a service, to address the four challenges in the four pillars. So in the project, we have a consortium from the quadruple helix. So we have research in academia like us, CMI, and the CUT, private enterprises like Columbia, INAPA Marina, Electi, the Levant, and Marine Fields. And the civil society, you have a Cyprus Shipping Association, and public authorities, the Cyprus Ports Authority, and also other foreign research organization, particularly University of Zagreb and Research Institute of Sweden. And this is how the project is structured. So we have the two work packages on management and dissemination and exploitation activities. And then we have a work package dedicated to equipment infrastructure, another one on intelligent data management for maritime big data. And then we have a three work package addressing four different use cases. We have work package 5 on maritime IoTs, situational awareness, and DSS, addressing safety and security. Work package 6 on regarding efficiency, in particular on port collaborative decision making. And work package 7 about the environmental monitoring, so addressing the environmental sustainability challenge. With work package 8 focusing on the pilot, so all across these three work packages. And so the objectives are to establish a comprehensive research and innovation infrastructure, developing an intelligent platform, conducting cutting-edge research on cyber-physical systems, improving efficiency of port operations, facilitate pollution monitoring, the marine biodiversity protection, and finally validating the infrastructure through joint pilot projects. So we are roughly halfway of the project, and now going to the details, the most interesting part. So in work package 3, we already engaged with stakeholders. We actually try to get their interest on during the duration of the project. Now moving to task 3.2, we identified already the locations of the test bed. So we have the Limassol port, the Columbia Ship Management floating labs, the CMMI IoT lab, and the Yanapa Marina. In this last one, we already installed a bispectral camera, which allows for enhanced 24/7 maritime surveillance, which allows to detect humans up to 3 kilometers and vessels up to 9, thanks to its position on a 100-meter high tower. We're also installing a long-range infrared camera, which allows for detection of vessels and objects without relying on thermal contrast. It will be put on top of a dry stack, 10-meter high. We'll have also fixed position cameras, which allow for people counting, crowd monitoring, security and threat prevention, and also allow detecting people falling into water. And we're also planning to install a weather station, air quality station, hydrophones, and lidars. At Yanapa Marina, we also installed recently high-performance servers in order to collect the data in a centralized manner and then process it locally. And then also people externally can access the data and perform some calculations. Now moving to Limassol, we are going to install AI-enabled cameras. One will be on a building 5-meter high, another one on another high structure. We'll also be introducing smart hydrophones, which can monitor ambient sound level, detecting maritime traffic based on the sound signature or underwater intrusions, and recognize all the unusual acoustic events. At CUT, we recently installed dedicated servers as well, again, for collecting and processing the data from the Limassol port and other locations. And at CMI, we have dedicated IoT labs completed with oscilloscope, bench power supply, soldering equipment, AI accelerators, and we'll be procuring also other equipment such as acoustical and optical modems, LiDAR, and hydrophones. And with Columbia, we will be developing a maritime vessel IoT, which include vibration sensors to be installed on the engine, from which also we will collect data from its ECU in order to track its health and operational efficiency, and also condition-based engine maintenance, as well as indoor air quality monitor from different IoT. And it will use a standalone offline server IoT system. Now, moving to work package 4, this is about intelligent data management. And in this case, we will be developing a platform which functions as a portal. So it will allow different users to access the infrastructure, resources, and services designed to be modular and scalable. And of course, we will be providing a detailed service catalog with pricing once fully developed. So it's planned on the use cases mentioned earlier and implement the following services: datasets, computational resources, access to equipment and hardware, access to test bed and labs, digital twin, DSS, and AI, business and technical consulting, and training services. And in task 4.2, we are developing a digital twin of harbor facilities. In particular, our partner Columbia has already recorded 3D images of Ayanapa Marina, so to create a virtual replica. And it will also integrate real-time data from IoT devices, sensor data, weather data, which then can be used for scenario simulation and prediction, for instance. And in task 4.3, we are dealing with data analytics. So the aim here is to develop on-demand services to support the tasks and the overall operation of the infrastructure. So the process will be to utilize the real-time data feeds as well as the historical data to build machine learning models to make predictions. For instance, the delay in shipping or fuel consumption or environmental accidents, and provide support results to the decision support system. And in task 4.4, LXT is working on the digitalization of smart contracts, focusing on 3 use cases. So consistent and secure rollout of firmware updates to IoT devices, capturing metadata of seawater samples and the validity of analysis results, and the seafarer training, certification, and crewing. And earlier it was mentioned the BIMCO guidelines on cybersecurity on board the ships, and this will also be taken into account in task 4.5 regarding cybersecurity and privacy, particularly referring to securing edge devices by identification and provide provenance for computer hardware. In work package 5, we are addressing IoT performance and characterization of edge processing. So to integrating different sensor, communication modules, power modules, and processing. And in terms of edge processing methods, we are including signal processing, of course, and also object detection classification methods, such as the one shown here, which is use case a pilot run at Ayanapa Marina. You can see we were using stereo cameras to detect moving vessels. You can see at the bottom that we are tracking its movement. Then in task 5.2, we are estimating and predicting methods for across the different devices. So we are collecting and fusing the data together and then challenging assumption of existing methods for tracking marine vehicles, people, speed of fire. And we will also consider novel methods for target tracking and assessment of health hazards and pollution spread. And in 5.3, we'll address cybersecure and resilient IoT networks. So identifying the threats, vulnerabilities, addressing risk exposure, developing protection and detection measures, and establishing contingency plans, and responding to and recovering from cybersecurity incidents. Now, regarding port collaborative decision making in work package 6, our colleagues at CUT are addressing challenges related to several loosely coupled organizations and distributed pieces of information that comes in port call processes. So there is a strong need here for standardized information sharing, real-time situational awareness, and collaborative decision making. Particularly in the port of Limassol, we have different actors as in all ports. So agents, custom, marine police, health department, immigration. Particularly for Limassol, we have 3 companies which use 3 different systems: P&O Maritime, Eurogate, and DP World. Then we try to gather all the data together with it's called the Perseus platform, which will be integrated into our MDGI platform in order to uniform all the data.
If I may add something here, yes. Alberto, if you can go to the previous slide. Representatives from Eurogate and TP World do participate in this project, and they will be with us in the pilot running of this program in March, and the full scale later in 2025. So they will also be able to present the opportunities, but also the real problems of new solutions from startups being integrated in their existing software as part of their digitalization strategy.
Great to know, thanks. Okay, so moving forwards, okay, you're probably familiar with AIS, so I will not spend much time on this slide. Probably know that it is used for predicting estimated time of arrival. So of course, we are trying using machine learning approaches to give better estimate than human. So the CUT has evaluated different algorithms. I will not go into details here. They evaluated different performance metrics. In conclusion, however, you can say that these techniques significantly enhance estimated time of arrival prediction accuracy, reducing reliance on inaccurate human agent estimates, and help ports save cost and improve operational efficiency. And in the future, they will incorporate additional data sources in real time, like weather, congestion, sea traffic, and they will integrate models into port operation system for real-time DSS. Of course, AIS can also be used for vessel trajectory prediction, particularly when moving towards hazardous area or potential collisions. They can assist in potential search and rescue operation and complete missing route data. So again, here machine learning can help. Okay, we'll skip this slide because I think I'm running out of time. We have quite a few slides already. So moving to work package 7, we have environmental monitoring for maritime activities. So the first task aggregates data from different in situ and satellite observation. So rerouting data from the infrastructure and other sources. It can be oceanographic, meteorological, and we try to address compatibility issue, building a database for archiving data from the EastMed, integrating the database into the platform for providing up to a week worth of data, for instance. CUT has performed some studies which are outside of my knowledge, so I will not go into details. Just mention that they used some artificial neural network to explore synergies between coastal water quality parameters. And another one was the use of probabilistic neural network for classifying Cyprus coastal eutrophication status. Again, going very quickly so that we can move to the next task, which is about visualizing the data-driven, visualizing data-driven environmental data. So we are, as I said earlier, we are collecting data from different air quality, water quality, and weather station monitors. So CUT has already developed a centralized data collection system in terms of meteorology, like temperature, humidity, pressure, air quality, so like carbon monoxide, dioxide, sulfur dioxide, nitrates, ozone, and particulate matter, as well as water quality. And we also plan to extend the data collection with more in situ measurement and satellite data. Here you can see a screenshot of their dashboard, which you can access at the address above. And in task 7.3, we are dealing with environmental pollution assessment using indicator, it's called GES, Good Environmental Status, implementing existing and or new thresholds of specific parameters, and integrating a GES assessment tool into the infrastructure and making accessible to external user as a service. Finally, in work package 8, we are running pilots to demonstrate the architecture. We already had a pilot in Ayanapa Marina with Turku University from Finland, where they ran a virtual reality fire extinguisher training, which was then compared with a real one. And more recently, just last week, we had a pilot use case, again at Ayanapa Marina, for a demonstration of autonomous underwater vehicle swim system. And we were also collecting sound with a hydrophone from CMI. So we'll play now some sounds. So this was sound recorded time. You can hear the boat engaging the drive in the first half, and then it becomes idle. Then the second sound.
I think there is a problem with the sound, Alberto, but if okay with you, we can share this presentation with everyone with the sound and everything later on.
Okay, never mind. So then I'll skip this slide. And okay, we've concluded. So in summary, we can say that digitalization in maritime industry can help improving, efficiency of port operation, as well as addressing environmental challenges. That's it from my side.
Perfect. Thank you very much, Alberto, for your presentation.